Namaste. In the previous session, we have seen this problem which is involved with the intersection of three sets. Generally, we take n of A union B union C as n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. I explained you that in the previous sessions. Let us move to the next laws of set theory. This is, you can say, laws of algebra of sets here. The first one, if you say idempotent law for any set A, we have A union A. It's nothing but A. A union A means it is nothing but A because union means R. A or A is nothing but A. That need not require any explanation. Similarly, A intersection A is equal to A because A intersection means and A is nothing but A. Similarly, identity laws. What is the identity set for A? A union phi is A because phi is the null set. Similarly, A intersection U is A. So what is that you have to understand? For intersection, identity set is U. For union, the identity set is phi. That's it. It is common sense. You can understand that. That is, phi and U are identity elements for union and intersection respectively. That's what I said now. Similarly, commutative laws. Commutative laws, everyone knows that A union B is equal to B union A. We will be seeing in the problems also again. That is, whether you write left right and right left makes no difference. That means commutative law holds good for the sets. Similarly, A intersection B is same as B intersection A. A delta B is equal to B delta A. That is nothing but the symmetric difference of A and B is same as the symmetric difference of B and A. Union, intersection and symmetric difference of two sets are commutative, obviously. A minus B is not equal to B minus A. You know that. What is A minus B? It is only A but not B. A minus B is only A but not B. What is B minus A? Only B but not A. So how they are equal? It's not possible. So A minus B is containing only A elements. B minus C is containing only B elements, and hence they are not equal. Similarly, A cross B is not equal to B cross A. What is that cross? We are going to learn that next. That is nothing but the Cartesian product. A cross B is not equal to B cross A. That is their cross product. That is the Cartesian product is not commutative. That is, difference and Cartesian product of two sets are not commutative, my dear students. Similarly, associative laws. If A, B, C are any three sets, then A union B union C is same as A union of B union C. Similarly, A intersection of B intersection C is equal to A intersection B intersection C. That means the associative law holds good for the sets here over union and over intersection. Similarly, the symmetric difference also holds good there. That is, A delta B delta C is equal to A delta of B delta C. Next, union, intersection and symmetric difference of two sets are associative. That's what we read so far. Now, similarly, the difference, if you take the difference of three sets, associative law, over the difference, A minus B minus C is not equal to A minus of B minus C. Even in the real number system also, it will not hold good. Similarly, A cross B cross C is not equal to A cross of B cross C. Unlike this one also same, A cross B is not equal to B cross A. Similarly, for three sets also, it holds good. So, difference and Cartesian product of two sets are not associative, my dear students. Understand that. So, let's move to the next part of it. That is distributive law. We did commutative law, we did associative law, we did first identity law, and all this we did. Now we are going for the distributive law. Very, very simple. Distribute in the name itself. That's what I've been telling you. Whenever you're getting doubt of any concept, take the meaning of that side heading there. Take the meaning of that side heading. What is the side heading there? Distributive law. Means we have to distribute the set. we have to distribute the set. It is just like we follow in the real number system. So what is the distributive law? What is the distributive law we are discussing about here is we have taken three sets here, A, B, C. We have taken three sets here, A, B, C, and we are writing the distributive law for these three sets. That is A union of B intersection C. Boys and girls, just see that carefully. A union of B intersection C is equal to A union B intersection A union C. That means it is simply distributed. That's what it is. And you understand that this union is distributed to B and C. In between, intersection is present. That's it. You can show that. You can show that through the Venn diagram also. You try that. Try that, you'll better understand that. What is the meaning of A union of B intersection C? Okay. And what is A union B intersection A union C? Let me show you that through the Venn diagram so that you'll be more comfortable. Like, let me take this to the board. That is, I'm discussing about this. This is the distributive law. My dear boys and girls, let us see on the Venn diagram. Just say this. If you check it out, this one is first one. Let me show through the Venn diagram, my dear boys and girls. See this one. Let me construct the universal set. This is the universal set. Let me show this separately so that you will be understanding in a better way. So what I'm doing, I'm taking one Venn diagram for LHS and I'm taking another Venn diagram for RHS. Let me show you that. So this is now, let me draw the universal set for LHS. Let me draw universal set for RHS. Okay? We'll be discussing that separately. Now, how many sets are given there? Three sets are given there, A, B, C. So let me take three sets here. Number one, this is A, let me say. Okay. Number two, let me take another one with another color. Let it be B. This is B, please. Okay. This is B. Now let me take another set which is C in a different color. That is, let me take one more set which represents C. Just to see this, my dear boys and girls here, this is what ABC. Now, let me write the sets names now. The first one, let me say this as capital A, this is capital B, and this is capital C. Okay, now let us check the LHS. A union of B intersection C. My dear boys and girls, let us write first B intersection C. This part is B intersection C, please. So let me show that in horizontal lines. Let me show that B intersection C first in horizontal lines. So let us draw that in this dotted lines in the yellow color. This is B intersection C, my dear boys and girls. This is B intersection C. Okay? It's clear. It's clear. Okay. So, after that, what is that to be understood? A union of B intersection C. Understand, my dear boys and girls, we have to write A union of B intersection C. So what does it mean? A union of B intersection C means you have to write entire A which is present in the green color. What for union stands for? Union stands for R, O or R. Either A or B intersection C. either A or B intersection C. Understand that. So I'm writing even that part totally. Which part? A and A or B intersection. The B intersection is already written. I'm writing A now. A. So let me take this A. I'm showing completely in horizontal lines. This is A. This is A, please. And this is also A. You cannot deny that even though it is a part of C, because A is a part of C also. So the yellow shaded region is nothing but the LHS. Yellow shaded region is nothing but LHS, my dear boys and girls. So A union of B intersection C is this. Now let us check what will be RHS here. Let us write 3 more sets here with the same color for the better understanding. That is, the first one is set A in the green color. Okay. Now set B in the blue color as usual. I'm taking the same color there. That is, this is set B. Okay. This is set B. Now let us take the set C in the pink color. Let me write that. This is set C. Just understand this, my dear boys and girls. I constructed the same here. Okay. But we are writing differently now. That is, we are taking A union B first. In between, what is that? You have intersection. Don't forget. A union B, intersection A union C. What is A union B? Let me write first A, please. What is A? This one is A. Okay. So A is this one, and B is this one, and C is this one. What is A union B? The entire A and B comes. Entire A and B comes. Next, A intersection C means entire A and C comes. In between, the intersection is needed. In between, the intersection is needed. A union B, intersection A, intersection C. My dear boys and girls, here you have A here. Here also you have A here. That is intersection A is common. Okay. So let me draw that again using RHS there. Using RHS, my dear boys and girls. Using RHS, just to see, this is A present in both of them. I'm writing that. This is A. This is A, please. The entire one. Because A is present in both. I wrote that. Now, what is A union B means? Common area of A union B is A intersection B. That A intersection B is a part of A union C. A intersection B is A intersection B is this, and it is A intersections A union C, please. A union C means A and C. A and C. So in between them, the intersection part for B and C is also to be considered here. B and C is also to be considered here. So how it goes? This goes like this. Just check it out, my dear boys and girls. Both are equal. Both are equal, and hence you can say that these two are equal. Just check it out. So the distribution, you don't have any twist in the formula, please, because it is straight away the distribution is done without any alteration, like whatever we do in case of real number system. The same is followed here also. A union of B intersection C is nothing but A union B intersection A union C. This union is distributed to B and C and intersection kept in between. That's it. And you can see through the diagram, both are equal. Similarly, the next one, A intersection of B union C, please. A intersection of B union C. So this is nothing but, again distribution, please. Again distribution. A intersection of B union C distribute this intersection to B and C. You keep union in between. That's it. Keep union in between. So what happens here? You will get A intersection of B union C is equal to A intersection B union A intersection C. So distributive law holds good for union and intersection. This is what you have to understand. You can comfortably distribute the sets over the brackets, over the terms of the brackets, over the sets of the brackets. This is about the distributive law.